the first step here?
The first step is to add like terms.
Okay. Gather like terms.
Yeah, gather, that's what I meant.
Okay. So what's my first step?
First step is...
Notice that it does not matter if I replace that with a different variable. I'll do that. Okay?
Yeah.
Doesn't make any difference whatsoever to the way you solve the problem.
No.
So which side should we put the x's on?
The x is on the left side.
Okay, how do I do that?
We subtract the 6 from both sides.
We want to do the opposite. Right now, the 6x is being subtracted from the right side. So we have to do the opposite. We have to add. Always do the opposite. Okay, so I'm going to add 6x to both sides. What's the next line after I do that?
7x.
Okay, first of all, what's 2 plus 6?
Oh, 8, I mean.
Okay.
Plus 11.
Okay.
Equals 15.
Okay, now what's the next step?
We subtract 11 from both sides.
Okay. And the next line?
8x equals 4.
And the next line?
And then we need to divide 8 by both sides.
Okay. What's the right side?
2.
Same mistake you made last time. I think we did this problem. Because you answered 2 last time also.
Oh.
Remember what we're doing. We're dividing both sides by 8, not 4. Okay? So, x is going to equal 4/8. What's that equal to? Does that simplify?
1/2.
Okay, so that's the answer. Okay, let's jump to slightly harder problems. Still, one variable only. You're going to find that the moment I introduce a second variable, that doesn't make it any harder. It's the same kind of problem. Okay, this is actually a harder problem than having a second variable. The one I'm giving you right now. What's the first step here?
Distribute.
Normally that would be if you think of PEMDAS, but there's actually an easier, a simpler first step that will get rid of a key denominator all in one step. How can I get rid of the 4 on both sides of the equation?
Find the like term.
Multiply the entire left side by the number 4 and the entire right side by the number 4. Notice how that gets rid. That 4 cancels with that 4. This 4 cancels with that 4. So now I've simplified it tremendously. I now have 3 times 4/5 x minus 2 equals 11. A lot simpler, right?
Yeah.
Okay. So this is a good example of where PEMDAS isn't always the correct thing to do when solving an equation. PEMDAS rules when you're figuring out the order of operations. But when you're solving an equation, you do whatever the easiest thing is to do. Okay? Now, second step. I could distribute that 3, or I could do what? What's an alternative second step? What's that 3 currently doing?
Multiplying.
Okay, so what do I need to do to get rid of it?
Divide.
Okay, so I'm going to divide the entire left side by 3, the entire right side by 3. Now I've gotten rid of the 3 on the left side, and I've simplified it even more. Now I got this. Okay? Remember, our goal is to get to the bottom and have x equal something. So what's the next step?
Add 2 to both sides.
Okay. It's going to get rid of it on the left. So I could write it if it makes you feel comfortable, but I don't feel the need to do that. It's kind of an unnecessary action. After you do enough equations, you won't need to do this. But for now, we'll go ahead and do it. So I got 4/5 x equals 11/3 plus 2. Well, how should I write that?
Sorry. 2 in front of the 11/3.
Well, I can't write it like this. That's multiplication. I could put an addition sign in front of that, but that doesn't really simplify it. In other words, let's convert the 11/3. What's the proper fraction for 11/3? How many thirds is that? Or I should say, how many whole numbers is that? Divide 3 into 11. What do you get? 3 into 11. What's the biggest number?
3.
How much is left over?
2.
So it's 3 2/3. You take whatever your remainder is, put it over the number. So that's 3 2/3. Well, when I add 2 to that, what do I get?
5 2/3.
Yeah, I can do it like that. For starters, turns out that's not the best thing to do, but you'll see why in a second. Now, how do I get x? I got 4/5 x.
Simplify it.
What's the next step? What do I have to do to get rid of the 4/5? Remember, this is my goal down here. I'm aiming to get x all by itself. So anything attached to it, I got to get rid of somehow.
So do we simplify the 4 by, and then we subtract it?
Can't simplify it. It's already simplified. How do I get rid of that 4/5? Well, let's do it in 2 steps. I can get rid of the 5 by multiplying both sides by 5. And then I can get rid of the 4 by dividing both sides by 4. So 2 steps would work, but 1 step is always better, and it's by multiplying by the reciprocal. Notice that if I multiply the left side of the equation by 5/4, the 5's are going to cancel, the 4's are going to cancel, and I'm going to be left with x. So I got to multiply the right side by 5/4 also. Now, I've got x on the left, but now multiplying this improper fraction by this proper fraction isn't really the easiest thing to do, but it would be easier if I could write that as an improper fraction. Well, how many thirds is that? If If I want to write that as an improper fraction, in other words, some number of thirds, how many total thirds is it?
That's one thing, or another.
The number 5 is how many thirds?
I'm not sure.
15 thirds would be the number 5. Just multiply the number by 3, and you get how many thirds it is. Okay, that's the number 5. Well, I got to add to that the 2 thirds. So I actually have 17 thirds. Okay, so in order to multiply these two numbers together, it's better if this is in an improper fraction. And then I'm going to multiply it by 5/4. Now, can I multiply those two? What's the answer? Can I simplify it? Can I do anything other than multiply numerators and multiply denominators? Can I cancel anything out before I attempt this multiplication?
No.
No, you can't. So, go ahead and multiply the numerator on a calculator. That's 85. What's the denominator in your head? 3 times 4?
3 times 4?
Uh-huh.
12.
Okay, so my answer is 85/12. Now the question is, can I simplify that? Well, the answer is usually going to be no. Because if I could simplify this, I could have done it back here when they were small numbers. In other words, 3 doesn't go into 85. 4 doesn't go into 85. And those are factors of 12. And 12 doesn't go into 85. So that most likely is the simplified answer. Okay? All right. Let's move on to 2 variables. This might sound like it's extra hard, but it's actually not. It's doing the exact same things that we've been doing. Okay, now, when you have 2 variables and only 1 equation, that means we're not actually going to be able to solve for a number, for x or y. You can only solve for x and y if you have the same number of equations as you have variables. Well, we have 2 variables here, only 1 equation. So the best I can do is solve 1 variable in terms of the other. Well, this question says, let's solve this for x, first of all. And then we're going to go back and solve it for y. How would you solve it for x? How do you get to this bottom? X equal. What's the first thing you would do?
You add 3y.
Okay, good. I'm going to write it in again. Up here, I'm just going to write it like that because that's where it belongs. So now I have 7x equals 8 plus 3y. What's the next step?
You add the 8 to the 3.
Hold on. You can't do that. In other words, that's an apple. Y's are oranges. You cannot add a number to a variable. I mean, you can add it like this, where I can write it like that, but that's the best I can do. But I can isolate the x pretty easy. What's going on with the x? What's happening to the x at the moment?
Oh, it has a 7.
It's being multiplied by 7.
Yeah.
Okay. So we got to divide by 7. Always got to do the opposite. And I have to divide both terms on the right side by 7. I can't just divide one of them. Okay, so now my 7's cancel. I'm left with the x all alone. And I now have 8/7, which is simplified, plus 3/7 y. So that's how I solve for x. Pretty straightforward. Really no different than solving for x when we didn't have a y.
Yeah.
I mean, it's all arithmetic. That's all you're doing is trying to isolate whatever variable it is you're solving for. Okay? So, now let's solve it for y. In other words, now I want to go through a similar process, only this time I want to have y equals at the bottom, or something equals y. I don't care if my y is on the left side or the right side, but I want it all by itself, and I don't want any y's over there. Okay? As long as I got y on one side and nothing but x's and numbers on the other, then I've accomplished it. In other words, there's a couple of things I could do here. I could add 4y to both sides, and that would make y on the left. But you don't want to do those kind of things, because then you have y on both sides of the equation. So what's a good first step to solve for y here?
Subtract 7.
Subtract 7x.
7x.
There's a difference. So I'm left with what on the left?
Negative 3y minus 7.
Okay, and that's as simplified as I can write it at the moment. Now what's the next step?
Add 3.
No. What is 3 currently doing? I know it looks like it's being subtracted, but it's not. What it's actually doing is it's a multiplier of y. And it's not 3, but negative 3 that is the multiplier of y.
Yeah.
But I can understand why you would think that what was being done was subtraction, because you're looking at this negative sign, but that's not a subtraction sign. That's a negative sign. And there's some places where you really want to be able to distinguish the difference between a subtraction sign and a negative sign. And this is one of them. So how would I isolate y? How do I end up with y equals? What can I do?
Divide negative 3 by everything.
Divide both sides by negative 3. What's the last line? Y equals what?
8 over negative 3.
Okay, that is the same thing as that.
Like negative 8 over.
Negative 8/3. And then what's this part?
Isn't it if two negatives divide, they become a positive?
Yep. So it's a plus.
Yes, it's going to be plus
7/3 x. Okay. Now let's talk about some of these things. First of all, this is the same as this, which is the same as this. Okay, so first of all, it doesn't matter where the negative sign goes. If it's negative, it can be in the numerator, the denominator, or out in front of the fraction. What's important is it's not this, because this would be a positive 1/2. Similar with variables. That is the same as that. Okay? All right. Let's do another separating variables. Now this is a little harder. But not that hard. First of all, let's solve for y. The first step for solving for y. We want y at the bottom equals.
Negative
Okay, so we're going to subtract x from both sides. Well, it's going to get rid of it from that. Now what?
Now do we divide by x?
There you go. In other words, it doesn't matter how complicated it looks. You just do the same exact things as if you had numbers. Now our answer is y equals 1 over x minus, what's that equal to? What'd you say? What's x over x equal to?
1.
Yeah,
1x.
1. Just 1, not 1x. In other words, anything divided by itself is equal to 1. It could be x cubed over x cubed. That's equal to 1. It could be 1/2 x divided by 1/2 x. That's equal to 1. But it's not, in other words, if I had x to the 4th over x cubed, that would be equal to x because you just subtract the exponents. When you're doing division of the same base, you subtract the exponents. So this is our final answer, 1 over x plus minus 1. Okay? As long as we're looking at this, let's talk about exponents, negative exponents. What does this mean? Now, what a negative exponent means, and lock this firmly in your memory, is it doesn't have anything to do with negative numbers. It's not a negative number. What it is a reciprocal. It means this. That's all it means. Well, 1 over 3 squared is 1/9. That's a positive number. Okay, so that's all negative exponents mean. So, when I had my last answer, which was 1 over x minus 1, I believe, I could actually write that as x to the minus 1. Minus 1. Not that I should. In other words, this is actually the best way to write it. They don't really like you to give answers with negative exponents. So you can always change a negative exponent to a positive exponent by moving it to the other side of the fraction bar. By that, I mean, if I had 1 over x to the minus 2, that's the same as x to the positive 2. Or if I had 3 over x to the minus 2, that's the same as 3x to the positive 2. So negative exponents are actually extremely simple. What's that equal to? Move the whole thing to the other side of the fraction bar in order to change its negative exponent to positive. So you're going to have a fraction, but what's going to go in the numerator and what's going to go in the denominator?
Mine's going to go up and then x is
going to be this.
Yeah.
So all I'm going to do, that's it. It's as simple and straightforward as that. It doesn't matter whether it's in the numerator or the denominator. If it has a negative exponent, move it to the other side of the fraction bar and change the exponent to positive. Okay?
Yeah.
All right. Got a couple of minutes. Let's go back and talk about solving this for x. We solved it for y. Okay? Solving it for x is quite a bit trickier. Notice why.
Yeah.
I could subtract xy from both sides, and that's going to leave x on the left side, but then it's going to leave also an x on the right side, which means I haven't solved for x. You've only solved for a variable as if you get it only on one side of the equation, okay? However, let's go back and do something. Let's factor out an x. Let's change this expression to x times 1 plus y. You see how that's true? Go backwards. In other words, start from here, multiply these two together, and you get this. Well, now what's the final step to solve for x?
Just add it all together.
No, you don't want to distribute it back. We just undistributed it. In other words, when you factor something, you're doing the opposite of distributing it. If I multiply that back together, I'm going to start with where I began with. So I don't want to do that. What's the final step of any equation? Divide by the coefficient. Well, let's take that x and write it there instead. It's the same thing. X times quantity 1 plus y is the same thing as 1 plus y times x. It's just now that you probably see the solution a little easier. What do I need to divide by?
1.
1 plus y. I got to divide this entire side by 1 plus y. And the entire right side by 1 plus y. Now, that 1 plus y cancels with that, and I'm left with x. X alone. And now I have 1 over 1 plus y. And that's my answer. But, in order to do that, we had to do factoring, which you and I haven't really talked about, but which is the next step in algebra, is factoring. And factoring is a big, long subject. Not sure we're going to be able to get through factoring before we get to solving two equations with two unknowns, which is what these three pictures, in other words, I still have the three photographs I took when I was at your house, and this is the material they told you to review. Well, notice what we're looking at here. We're looking at each equation has an x and a y in it, but I can't solve for the values of x and y unless I have a second equation. Well, there's some tricks you can do when you have two equations and two unknowns that allow you to actually solve for a value for x and a value for y. So we've got to get to this point here before you do your test, before we're done. So I'm kind of going on that pace. But the next thing to talk about really is factoring. So factoring is what we'll do next time.
All right.
Okay?
Yeah.
All right, Chris, I will talk to you next time.
All right. Thank you.
You're welcome. Bye-bye.